students, today we are going to see some interesting and important questions from Narendra Avasthi sir, physical chemistry, and the questions from redox reaction. Come on, let us discuss the first question. Phosphorus as the oxidation state of +1. So, +1 oxidation you can find in among which one is having +1 oxidation. That is phosphorus they are asking. So, if we know the formula, easily we can identify the answer. Now, option A, it is orthophosphoric acid. That means H3PO4. Option B, it is phosphorus acid H3PO3. And C option, hypophosphorus acid H3PO2. And last one, D, metaphosphoric acid HPO3. Right, come on, let us find the answer here. Now in that, here oxygen usually having oxidation state, it is -2. Hydrogen, it is +1. Okay, now that means X. This is phosphorus is X, easily you can identify. I hope you know how to identify the oxidation state. This is -8, right? So this is oxygen. So oxygen is having -8 in this point. Okay, now here hydrogen is +1, so this is +3. So that means this is actually +5. So this phosphorus having +5. So that means this will not be the correct option. They are asking about +1. So that means this will not be the correct option. And the same way, this is -6. This is +3. So naturally, this will be +3 only. So this also will not be the correct option because +3 it is there. They are asking +1. And the same way, this is -4 and this is +3. So that means this is +1 oxidation state. So they are asking about +1. No, so this is exactly the correct. Anyway, let us check this also. Now this is -6 and this is +1. So that means this is +5 oxidation state. I hope you got that idea now. Which is the correct option? Option C is the correct option. C is the correct option. Yes, got it. So if you know the formula and you know how to deal that oxidation state formula and solving the type, I hope you got that idea. Come on, let's go to the next question. Next question, oxidation state of chlorine in calcium oxychloride, that is bleaching powder, as which is the correct option. So calcium oxychloride is another name of bleaching powder. It is calcium hypochlorite, CaOCl2. CaOCl2, it is calcium hypochlorite. Right, now here, how do we bring that answer over here? Very simple. CaClO and Cl. See, here oxidation state, it is +2 because it belongs to second group, S1 and S2. So that is S block elements in the calcium +2 oxidation state. And here, this oxidation state, it is +1 oxidation state. Whereas here Cl, it is a -1 oxidation state. Now, what is the correct option? You yourself will answer. This is +1 for one chlorine atom is actually ClO minus is having +1 oxidation state, right? And that another Cl, this is another Cl is having -1 oxidation state. So option C is the correct option, +1 and -1. I hope you got the clarity. Come on, let's find the another question. The next question, oxidation number of sulfur in S8, S2, F2, H2S and H2SO4 respectively are. Okay, now let us identify one by one. Now S8, it is actually S8, it is 0. How do we identify it is 0? Due to same kind of atoms present in it. This is due to same kind of atoms, right? So that is what it is 0. Now the second one, S2, F2. So what is the answer? You will bring it here. F2, that is actually -1. So you will get -2. So here you have to identify this is X. So 2X. So X equal to +1. Right? This is +1. And the same way. So this is another one, H2. Yes, hydrogen sulfide. So this is actually we don't know. And this is +2. How do we identify it as +2? Here H plus hydrogen, it is +1. So it is 2, it is there. So automatically it is 2 plus. So here 2 plus means -2 here, just to the opposite. So here you can identify -2. And next one, what it is? H2SO4. H2SO4. So H2SO4, how do we identify? I just draw the structural formula here. Yes, a double bond O, and this side also double bond O. Here oxygen which is connected with hydrogen, and the same way just oxygen connected with hydrogen. Now oxygen it is 4, yes it is there, and sulfur 1 atom, hydrogen 2 atom. Yes, now what is that oxidation state of sulfur? It is very simple. Now this is X and this is +2. So this is hydrogen, it is +1. So 2 it is there, so +2. Now it is -8. Now what is the oxidation state? Definitely it is +6. Okay, now what is the exact way? 0 and it is +1, -2 and +6. So which is the correct option? 0, +1, -2 and +6. So option A is the correct option. I hope you got the clarity, and please identify how to deal the oxidation state very clearly. Yes, come on, let's go to the next question. iron Fe shows an oxidation state of +1 in these compounds. Which one is showing +1 oxidation state of iron? The first one, option A, tells about FeCO 5 times. So usually carbonyl group, it is 0, that is oxidation state, it is 0. So 5 into 0, it's 0 only, whichever multiply with that anything, that is. So this oxidation state, it is 0. So this is wrong. Option A, it's wrong. Option B, let us check what it is. Option B, FeH2O 5 times NO and SO4. SO4. Now, in this point here, this is inside that, what it is, coordination sphere. In that H2O, it's a neutral compound, so oxidation state, it is 0. So 5 into 0, anyway, it is 0. This is X plus 0 plus nitrosonium, always nitrosonium ion, it is +1 oxidation state. So here +1 equal to sulfate ion, it is -2. So this is -2. So that means here X equal to, here what do we identify? Here +1 oxidation state. Why you know? Here -2, here +1. So X equal to +1 oxidation state. Right now, third one, what it is? Fe4, FeCN6 thrice. So we can write it in this way. FeCN6, this is ligand, and inside that sphere, this is thrice, and here 4 minus this point, I just bring it out. So to calculate that oxidation state, so this is X plus, always cyanide, it is -1. So that means 6 into -1 equal to -4. So that means X equal to +2 oxidation state. So this is +2. And the last one, FeCl4 minus. So the minus they themselves have given, so nothing to worry, easy to identify. X plus, always Cl, it is -1. So 4 into -1 equal to -1. So X equal to +3 oxidation state. I hope you got the clarity now. Which is the correct option? You are getting here X is +1. That means iron, it is +1. So this point here, what it is? FeH2O 5 times NOSO4. So this is nitrosonium, it's a +1, and a neutral compound, it is 0, and this is X, and sulfate always -2. So this iron shows +1 oxidation state. I hope you got the clarity which compound gives +1 oxidation state. Option B is the correct option. Come on, let's go to the next question. The oxidation number of sulfur and chromium in the final product respectively. This is very simple. Here potassium dichromate, so directly I can write that formula, K2Cr2O7 plus SO2 in that acidified H plus acidified potassium dichromate only they have given. So the final product, it is K2SO4 plus Cr2SO4 thrice. Right, so I'm not bringing the point of balancing equation. I wanted to identify the oxidation number of sulfur and chromium and the final product respectively. Yes. Okay. Now here oxidation state, it is oxygen, it is -2, and potassium, it is +1 because it belongs to first group category. Right. Okay. Now this is -14 and here +2. So naturally here you will get what it is, +6 oxidation state. So chromium, it is +6 oxidation. And the same way sulfur, what it is here, oxidation state -2. So you will get -4 and here you will get +4. In this point, sulfur, it is +4. Now let us check the product of sulfur and chromium. In this point, we have to identify sulfur, and in this point, we have to identify chromium. Right. Now here what it is, oxygen, always it is -2. So that means here -8 and this is +2. So naturally you will get +6 oxidation state of sulfur. And the same way here, sulfate only we have to consider. We cannot bring the point of here oxygen, sulfate only. Because why? We are using that, we are going to find out chromium only. Right now sulfate, it is -2 into 3. So that means this is -6 oxidation state. That means here 2x. So x equal to +3. So chromium and sulfur, here what it is, sulfur, it is +4. It's converted to +6, right? And the same way, chromium, it is +6. Chromium, it is +6 converted to +3. So that means sulfur, it's getting oxidation, and chromium, it's getting reduction, right? So that means reduction, right? So oxidation and reduction, you are coming to know very clearly. So +4 converted to +6. So this is oxidation. And the same way here, in this point, +6 is converted into +3. So this is a reduction and this is oxidation. All right, you got that idea how to identify. So here +6 and +3. Now +6 and +3, which is the correct option? +6 and +3. Option B is the correct option. Hope you got the clarity how to identify. Yes, come on, let's go to the next question. Nitrogen atom in NH4NO3. Right now, this is very simple. Nitrogen atom only they are asking. So here NH4NO3. Right now, this is overall charge of ammonium in that nitrogen, overall charge of nitrate in that nitrogen. Let us identify. So here hydrogen, it is +1. So that means this is +4. Right now, overall charge of ammonium ion, ammonium ion, it is plus 1. So that means this nitrogen, it is X plus 4 equal to plus 1. So X equal to minus 3, right? So X is what it is, nitrogen. This nitrogen is having minus 3 oxidation state. Now this side here, NO3, right? That means overall charge of nitrate ion. So nitrate ion, what it is? Minus 1. So here actually oxidation state of oxygen in this point here minus 2. So here minus 6 and this is X. So here in this point X plus minus 6 equal to minus 1. So here X equal to what it is? Plus 5 oxidation. So nitrate ion oxidation state in that nitrogen atom, it is plus 5. Ammonium ion in that nitrogen atom, it is minus 3. So what is the correct option? Minus 3 and plus 5. So which is the correct option? Option C, minus 3 and plus 5. Hope you got the clarity how to identify. Yes, come on, let's go to the next question. The next question, oxidation state of sulfur atom in Caros and Marshall's acid. So Caros and Marshall's acid, if you know the formula, easily you can identify the oxidation state. So Caros acid and Marshall's acid. Marshall's acid. Right. Now Caros acid, what is the formula? H2SO5. H2SO5. Right. And the same way Marshall's acid, H2S2O8. Now in this oxidation state, oxygen usually minus 2 and hydrogen plus 1. So you will get here this side minus 10 and here you will get plus 2. So that you will get that what it is, plus 8 oxidation state. Sulfur usually you will get maximum plus 6 oxidation state only. It cannot be plus 8. So the answer will be plus 6. You know Caros acid. What is the name of the Caros acid? You know here it is peroxo monosulfuric acid. Sulfuric acid. Right. Now the next one here H2S2O8. Now here also the same oxidation minus 2. So that means you will get minus 16 and here plus 2. So here what you will get it minus 14. So minus 14, right, divided by 2. Here 2x no, divided by 2. So you will get 7. Actually sulfur atom, it cannot beyond that plus 6. So here plus 7 it has mentioned. So it is not correct. So plus 6 only. So what is the name of Marshall's acid? Here disulfuric acid. Here peroxo disulfuric acid. Sulfuric acid. I hope you got the clarity. Both the sulfur atom, it is having plus 6 oxidation state only. And Caros and Marshall's acid, you know, that is Caros acid, it is peroxo monosulfuric acid. Marshall's, it's peroxo disulfuric acid. I hope you got the clarity about this. Now, which is the correct option? Plus 6 plus 6. So the answer, it is option A is the correct option, plus 6 and plus 6 of both the acids. Come on, let's go to the next question. Now, the next question, in which of the following oxidation number of oxygen has been arranged in increasing order? They are asking about the oxidation number of oxygen. Now let us find out. The first one, OF2. Just I brought the same thing only. Only thing I did not mention increasing or decreasing because we have to identify the oxidation number. Then finally we can conclude that. Okay, now here OF2, KO2, BaO2 and O3 ozone. Right now halogen fluorine, it is minus 1. So here it is 2, it is there. So here we can bring it here. It is actually what it is, minus 2 oxidation. I just changed the color. So here minus 2 oxidation. So naturally this is plus 2 oxidation state. And the same way here plus 1 oxidation because it is potassium first group category. So it is plus 1. So here O2 it is there actually. So this is plus means that means this is minus. So in that plus 1 that means it is minus 1 but O2 it is that. So that is minus 0.5 it will be there. I hope you got the clarity. Now the next one BaO2. So that BaO2 it is plus 2 oxidation state. And here O2 it is there. Actually it is minus only plus 2 but here what it is, each oxygen they are asking, that means here minus 1, right? That is what each oxygen. Right now ozone it is 0. Now do you think it is having increasing order? Plus 2 0.5 that is minus and here minus 1 and here 0. No, this is not the correct option. And here what it is, the same thing we can bring it over here. Here what it is, minus 1 of oxidation state. Right now first one we found, no, then other than that it will be easy. So this is minus 0.5 and here 0 and this is what it is, plus 2. So that means minus 1 minus 0.5 0 plus, yes, it is actually what it is, increasing order. Yes, it's correct. So option B, it's correct. Now let us check other points also. Now the same way here BaO2 it's minus 1 and here ozone 0 and here what it is, plus 2 and this is 0.5 minus. No, this is not the correct option and this is also not the correct option. And the same way last option here what it is, KO2. So it is actually here minus 0.5 and here plus 2 and here ozone 0 and O2. So BaO2, it is -1. So this is not the correct way. So increasing order, option B. I hope you got the clarity about that option B. So which is the correct option? Option B. Yes. Option B, BaO2, KO2, O3, and this is the correct option. I hope you got the clarity. Come on, let's go to the next question. Yeah, next question also, last question, same, it is repeated. Now, the next question, the oxidation number of oxygen in KO3, Na2O2 respectively. Yes, come on, let us find that KO3. Here what it is? KO3, Na2O2. So usually potassium and sodium and all +1 oxidation state, right? Because it belongs to group 1. Right now this is +1, and of course this is minus category, right? So that means plus 3x. This only we have to identify. See, oxidation number of oxygen they are asking. So 3x. So here that means what is the answer you will bring it? So 3x equal to -1. So x equal to -1 divided by 3. So that means you will get what it is, minus 0.33. So this is the oxidation number of oxygen with KO3. Right now, next one here in this point, oxidation number. Here sodium, it is +1 only. So that means this is +2 and this is 2x. So here, so that means 2x equal to here what it is. So 2 plus 2x. So x equal to here -2 by 2. So you will get 1. Right. That is -1. Right. So this is -1 of Na2O2 of oxidation number of oxygen. Right. Now this is minus 0.33 and here -1. So which is the correct option? Option D is the correct option. Minus 0.33 -1. Yes, it is correct option. Hope you got the clarity. Now this question already we have seen in the last question, that is B option we found. Right. Come on, let's go to the next question. Oxidation number of phosphorus in BaH2PO2 twice. Right, now let us write that BaH2PO2 twice. Right, now Ba, it belongs to second group element, so naturally you will get what it is, +2. Right, and here hydrogen, it is +1. So here 2 it is there. So here, and this is X, and this is oxygen, it is -2. So you will get what it is, -4. Right, equal to 0. Right, now here in this +2 and here 2 plus x, here -4 equal to 0. So here in that 2x -2. So this is -4 it is there, no? So that means here -2 equal to 0. So that means here x equal to, here what it is, +1 oxidation state. So x equal to +1 oxidation state. So here +1 oxidation state, which is the correct option? Option B is the correct option, +1 oxidation state. Right, now the next one, here they have given, if it is known that iron at a 0.96 oxygen and iron Fe is present in +2 and +3 oxidation. Mole fraction they are asking. So one it is 0.96 and another one we have to identify. So +2 and +3 oxidation state. What is the mole fraction of Fe2 plus and the compound? Come on, let us identify. This is completely mole fraction. So come on, let us discuss. Here in this point, here Fe. So Fe2 plus and Fe3 plus. So Fe2 plus, let us check with that x. Let us think it is a x. And Fe3 plus, it is 0.96 minus x. So from this mole fraction only, no? So from in this way we can identify. Okay, now in this overall charge of oxygen, overall charge of oxygen, oxygen, it is -2. Okay, now let us write at this point. So this is actually Fe2 plus and Fe3 plus. Let us write here 2x. Why we are writing 2x? This point, right? Now 2x plus here 3x, right? So this is 0.96 minus x equal to 2. I just put it +2. Why? Overall charge of oxygen, it is -2. Let that positive charge, the total positive charge must equal to negative charge. That is what I just mentioned, +2. Right, now the next point what I wanted to write, here 2x is there, plus here 3 of 0.96 minus x equal to 2. Right, now let us multiply this point. So here what it is, 2x plus 3 into 0.96. So you will get 2.88 minus 3x. So both you have to multiply this and this and this and this, right? So equal to 2. So here 2x and 3x. So what you will get it, minus x. So minus x plus 2.88 equal to 2. So here what it is, minus x equal to, here what you will bring, 2 minus 2.88. So you will get x equal to what it is, minus x equal to minus 0.88, right? So now mole fraction, this is completely based on mole fraction. So mole fraction. So mole fraction equal to what it is, Fe2 plus. Fe2 plus only we have to identify. So Fe2 plus equal to moles of Fe divided by total moles. Right now, moles of Fe2 plus, this is right now in this point what they have given 0.88. Yeah, this and this will be cancelled, so you will get positive x equal to what it is, 0.88 only. Why? Because minus and minus both will be cancelled, divided by 0.96. This is total moles, right? So you will get what it is, moles of Fe. This is moles of Fe only, mole fraction of Fe. So this is 11 by 12. So 11 by 12, or if you calculate this point, 0.9167. This is mole fraction only. So Fe3 plus will be 0.96. Fe2 plus will be 9.167. So mole fraction, there is no unit. So 11.11 by 12, that is, or else here 0. Which is the correct option. So 11 by 12. So 11 by 12 is the correct option, or else here, or suppose another answer 0.9167. This also will be the correct option. I hope you got the clarity. If they are giving such kind of answer, you can answer for this, or else you can find this. So usually if they are giving such kind of question, you just to take one point, it is x, the other point, it is 1 minus x, in that way, so that you can calculate, and finally you're bringing the answer. I hope you got the clarity of these two questions. Yes, fine. Come on, let's go to the next question. I hope you understand all these questions, whatever explanation from this book, and thank you for your great support, and thank you for watching.